Hello and welcome to this video. Today we are going to review how to use the plotting software Grace. So of course, when it comes to plotting data, the data that you generate during your research, you can use, for example, Excel, which is a fast and easy way to make plots. But when it comes to publishing nice plots or to make a presentation, the quality of the plots that are generated by Excel is not enough to have high, good-looking plots. So for this, you will need to use a dedicated plotting software, and Grace is a very popular one, although it might not be the most popular or the most easy to use. The good thing about Grace is that it's a free software that you can use on various platforms like Windows, Linux, or Mac OS. It can be sometimes a little bit difficult to install depending on which platform you are using, and it's not always easy to use, but that we are going to review here the basic features of this software and how to make your first plot. So if you run Grace for the first time, this is what it would looks like. So you have just an empty basic plot that we will need to feed with data and to make look good. In the future, you will have some templates that you can use. Once you are when you have defined the styles of the plotting style that you want to use, you will not have to edit the style of your plot over and over again. You can just save either a given plot and just modify this plot the next time so that you don't have to do all the changes again, or you can save all the settings for a given file and use it for your other file so that you keep you have consistently looking plots that you don't have to change the setting over and over again. So the first thing that you will need to do after you use and you open the Grace software is that you need to load the data that you want to plot. So the way to load the data, you will need to have your data in a text file that contains the data in the forms of columns. Grace cannot directly read data from an Excel spreadsheet, so you will have to copy and paste data from Excel into just a simple text file. So here, for the purpose of this demonstration, I have created a small text file, so it looks like this. So you have just 3 columns with 3 data sets, and this is what we are going to use for this demonstration. So here, what we are going to do is to load those data into Grace. The way to do that is to go into the data folder and choose import. And here you have only one option, which is to import ASCII data. So here, then you arrive into this window, which allows you first to look at in which directory you're going to find the data file that you are looking for. So here we are already in the right directory. Then you have the list of the files where that are present in this directory. So here we are going to select this one, which contains the data that we want to plot. Then Grace is asking you on which graph do you want to import the data, but here we have only one graph, G0, so there is nothing to choose from. And then the important thing is, how are you going to load the data? Are you loading a file that contains only a column that is going to be your X and another column that is going to be your Y? Or is it going to be a more complicated scheme? So here, for example, in this set of data, we have 3 columns. The first one is going to be our coordinate X, and the 2 second ones are going to be 2 different coordinates Y for 2 different sets of data that we want to plot. So in this case, if you load the data as single set, Grace will just assume that the first column is X and the second column is Y, which is the case for many files, but not the case, and it's not the case for this file. So here we will have to choose block data, which will allow us to choose what goes on X, what goes on Y. In this case, if you choose this, you have a second window that pops up, which asking you which column do you want to put on X and which column do you want to put on Y in the plots that you are going to be creating. So here in this case, in our files, we have 3 different columns. We want the first one to be the X, and then the second one is going to be a Y. So we are going to first choose this setup where the column 1 goes on X and the column 2 goes on Y. Then, so we are applying. At this point, the XMGrace has loaded this first set of data. Then we are going to load now the second set of data. We want to plot on the same plot the two sets of data. So again, we are choosing the same file. We are choosing block data again. And this time we are going to say, I want to load on the graph G0 to put the column 1 on X. This doesn't change, but this time I want to put the column 3 on the column Y. Okay, so I'm going to apply this, and now I have the second set of data that has been created. So here we have already a simple plot which contains just the raw data. XMGrace has created some lines in between the data points, and they are plotted as a function of the column X. But at this point, we are still very far away from having a final plot because we don't have the data are not plotted in the proper way. We don't have any axis symbols, etc. Then the second thing is going to be to take care of the axis. So the axes are always very important in scientific plots. You always need to specify what is plotted as a function of what. And if relevant, you will need to put the units. So here, those are just two example data sets, just two distribution. So here you can see those two plots, for example, as just the fraction of students getting different grades. So you have different grades that are on X, the grades going from 0 to 10, and on Y you have the fraction of students that got these grades. So if you take the sum of all those fractions, you would find 1 for both of the data sets that we have. Those two data sets may, for example, correspond to two different classes. So for the black data sets, the average grade that the students got is around 5, and for the red data sets, the average grade is somewhere around 2 and 3. So the first thing is we are going to see is how to change the axis. So for this, you can either directly double click on the axis, or you can go to the plot directory and set the axis properties. Okay. So here we have the menu that shows the axis properties. This is where we can change all the properties, all the settings of your axis. So the first thing to choose is which axis do you want to work with. So we can work on the x-axis to start with, and then on the y-axis. The first important thing is to determine what is the minimum and maximum value of your axis. So here the axis is starting at 10. Is starting at 0 and ending at 10, which is good because this is the beginning and the end of our data, so we don't want to change things. You can choose if the axis is going to be linear or, for example, logarithmic. So for example, if you change this to a logarithmic axis, XMGrace is going to create a logarithmic x-axis. So here in this case, we don't want a logarithmic axis, so we are going to come back to linear. Then the next thing is to choose the label string. So the label string is the title of the axis. So here in this case, since we are talking about the distribution of student grades, we are going to say that this axis is student grade. So when you do that, it creates the title of this axis. Then the next thing is that you need to choose how often do you want to put a label. So you need to choose if you want to, what kind of numbers do you want to have on your axis. So here we are going to, for example, to have, we can say we want a number every 2, a grade of 2, and we are going to put, for example, when you need to choose how many minor ticks do you want in between two labels. So we are going to choose here only one minor tick, which means that you will have one big tick, which is every 2, a grade difference of 2, and you have one small tick in between two major tick. Here we are going to choose that the axis start from 0 to 10 so that we have a nice looking axis like this. Then the next thing is that you might want to change the font that is used for your axis label. So here the default value is Times Roman. I recommend using Helvetica, which which improves the readability. So then we can just continue to go from window to window to change the different useful settings for this axis. The second window here, now this is the properties of the labels. So here we are going to choose again Helvetica to change the font for the axis label. We can change the color, we can change the font size, but here black and a size of 100 is fine. You can choose the side where the label is going to appear. So we are going here to choose the normal side, but you could choose the opposite side also if you wanted. Then we are going to move to the tick labels. So here you can choose first the size of the labels, and if you want any given angle. So here we are not going to change anything here. The next thing is the tick marks. So here what we are going to do is to decide that presently they are pointing in. If you have ticks that points in, it's perfectly fine, but usually it can overlap with the data. For example, you can see here the tick is overlapping with a data point. So to avoid this problem, we can have the tick pointing out, and in this case you don't have any risk of ticks overlapping with data. So then we are going to move to the y-axis and basically do the same. So we want the axis to be, for example, named the distribution. So since we are talking about the grade distribution, okay. In this case, we can choose the major spacing to be every 0, 1. So this is good. Minor ticks, just one minor tick in between two major ticks. This is good. We are going to change the font to Helvetica again and just redo what we did to choose the font to be Helvetica for the labels and to choose the ticks to be pointing towards the outside to avoid any potential overlap with the data. Here, one thing that is good to change is that you have here an axis that doesn't look so good because you start with 0 and then you go to 0.1, 0.2, 0.3, etc. So you don't keep always the same number of significant figure. For example, the first the first label is just 0, so only one significant figure, and then you have 0.1 which has two significant figures, so it doesn't make the axis look very symmetric. So you can change the format of the labels here by changing. You have different types of format. You can use power, scientific, etc. So here we are going to use the decimal format. If you choose the decimal format, you can specify what is the accuracy, the precision that you want. So here we are just going to choose a precision of 1, which means that you have just one figure after the point, so that you can keep a consistent number of decimals after the point so that the axis looks better. Okay, so now that we have the axis set up, now we will want to take care about the graph itself. So for this, either you can click on the graph, or you can just go into the plot and graph appearance menu. And here you can change different options. The first one that is going to be important is to change the size and the shape of the graph. So why do you do that? Because first you want all your plots to have exactly the same shape and the same size to be consistent with each other. And also here we start with a plot that is rectangular, which sometimes is good, but in a lot of cases it's going to be better to have a square plot. When you change the shape of a given plot, the shape is very important when you plot things. For example, if you had a very elongated plot like this, it becomes very hard to see the variation of the data. And if you have, on the other hand, a plot that would like this, then you put a lot of emphasis on the maximum and the minimum of your data sets. So usually the most neutral and elegant way to plot things is to have a square plot. So you can change the dimension of your plot by double clicking on one of the corner and then just adjusting the size and the shape of the plot like this. But when you do that, it's very likely that you will get two different sizes every time you do this operation. So you don't want to have an arbitrary size. So an alternative way is to just use this graph appearance menu and to manually specify what do you want to be the position and the dimension of the plot. For which you can specify the viewport option here, which tells you what is the minimum position X and maximum position X, minimum position Y, and maximum position Y of your plot. So for example, here we are going to choose the minimum X to be at 0.15. We are going to choose the maximum X to be at 0.6. We are going to use Y to go between 0.45 up to 0.9. So you have, in this case, we will make a square plot which have the same dimension on X and same dimension on Y. Okay, so if you apply it to this, now we get a nice little square plot. So note that this is not the X, those values of X and Y are just the position of the plot in the space that we have here in XMGrace. It doesn't have anything to do with the X and Y value that you have, the data that you have inside your plot. This is just to determine the position of the plot itself. Okay, so now we are going to look at the different other options that we have. So we can, if we want, add a title to the plot, but typically we don't want that. We will just add a caption manually using Word or using LaTeX behind the plot, so we don't need that. Here you can choose different options for the frame itself. So here what we are going to do is to slightly increase the width of the plot to make it look more sharp. So we can just increase the width to 1.5, which increase the visibility of the plot if you are going to present it at conferences, for example. Okay, and then you will have different options for the legend box, which we haven't specified yet. So we will come back to this later. You have all those different options for the legends, etc. Okay, so here, if we look at this, something that doesn't look so good is that you have a plot width that is 1.5, but the ticks are just 1. So we are going to go back to the axis and change this by going to the tick marks and also increase the width of the line ticks, both for the x-axis but also for the y-axis. That way it looks more consistent. Okay, so at this point we have specified the axis properties. We have specified also the graph properties. So now the next step is to change the style of the data themselves. So here by default, XMGrace has created two data sets. One is in black and one in the red color. At this point, we don't know where the data are. The only thing that XMGrace has been doing is to join those different data by a line. Okay, so we are going to change this. To change the properties of the datasets themselves, you can either double click on one dataset or to go into the plot menu and set appearance. This is going to change the parameters for the data themselves. The first thing is that you want to select the dataset that you want to work with. So here we have two datasets, which is S0 and S1, and those two datasets belong to the same graph, which is G0. We have only one graph here. And then you have different options for the datasets. The first thing is that you can choose the format. So we could, for example, if we needed some error bars, we could specify that instead of having just X and Y, you would have X and Y plus an error bar on X and maybe an error bar on Y. So this can be changed here. And then here you have the different properties for the symbols. So those are going to be about the data themselves, and the lines, which are the lines that join the symbol together. Okay, so we are going to first add some symbols for the plots. So here there is no symbols yet, which means that you don't see the points individually, you just see lines in between the data. So we are going here for the first data sets to use square symbols and click apply. So here what XMGrace has been creating is creating some square symbols for each data that we have imported inside Grace. Then the second thing that we can do in this case is to remove the lines in between the symbols. If we just keep the lines like this, the plot is going to look very pointy, although there is no reason that the real data should be that pointy. So we are just going to remove it, and we will add some other kinds of lines later. Then we can add a legend. So here, those are two different distribution of grades for two different classes. So we can say that the first distribution of grades, for example, is for CEE 105, which could be the name of the class. And the second one that we can change here is going to be for CEE 106, let's say. Okay. So now that we have this, let's come back to the first data set and let's explore the different options that you have. So the next menu is about the symbols themselves. So here you can change different things like the styles that you are using for the symbol, etc. Here the thing that we are going to change is that here by default the symbols are empty. You just have the outline of the symbol, but there is nothing inside. What we are going to do is to fill those symbols so that it improves the visibility of the plot. So you can change the symbol fill. At this point the pattern is none, which means that nothing is going to be filled, and we are going to change the pattern to be full like this, so that now the data are fully filled with in black. So we can do we will do the same for the second data set later. So let's continue to explore. Those are the properties for the lines. Here we don't have any lines in between the symbols, so we don't need to change this. Then you have other different options, for example, for the error bars, etc. But here we don't have any error bars. So now let's move to the second set of data, so the red set. Again, we are going to add some symbols. This time we can add some diamond symbol like this. We will remove the lines in between the symbols, and we are going to again choose a full pattern to improve the visibility of the plot. Okay, so here one thing that we need to talk about is the legend. So we have added some a legend to distinguish the two data sets from each other. Whenever you have two different or more than two data sets on the same plot, you will need to specify which one is which, so you will need a legend. So here a legend has been created by XMGrace, but this legend is not at the right place and doesn't look so good. So we are going to go back here to the graph appearance and change this legend. So we are going to go to the legend box. The first thing is to change the position of the legend. So here we are going to try to move it so that it goes back inside the plot. So for example, let's put it at like this at 0.4. We are going to move it up so that it goes in the corner. So for example, we can put it at 0.88. Okay, so here now we have a legend that is at the right location. One thing that we will want to do is to remove the rectangle around this caption that doesn't look so good. So we can, for example, do that by changing the frame line around the legend and putting a pattern of none to remove the line. We can also remove the filling inside the legends. This is to avoid that the legend has any risk of overlapping with the data points. And the last thing we would want to do is to change also the font of the legends. We will want to use Helvetica to have a consistent font for all the text in our plot. Okay, so here everything looks good. So now we have a plot that looks good. The axis look good. The size and the shape of the plot looks good, and we have put the relevant style for the data sets. Now the next thing is that we will want to work with those data, change those data, and add some feature to make this plot look better and easier to read for the reader or whoever you're going to present those data to. So this is going to be now about transforming data. Okay, so the first thing that we will want is, for example, here the distribution of the values are as fraction. So it means that here, if you look in the black distribution for CE 105, this means that a fraction of students of 0.2 got a grade of 5. So here, for example, we might want to change this into percentage of students. So for this, you will need to change the data. You will need to multiply the data by 100 to have the data in percentage and not in fraction. So for this, you will want to transform the data. So for this, you will go into the data menu and go to data transformation. And here you have a whole range of different options that you can use to change and to adjust the data, modify the data. In this case, we want to use the option evaluate expression, which can be used to do some simple mathematical operation on the data. So here, the only thing that we want to do is to multiply all the y values of those data sets by 100. So we are going to select the data that we want to change. And here we have to decide if we want to do an operation on those data and to create a new data set, or just change those data and to replace the new data set, to replace the data by the new data that we will have to create it. So here we just want to change those data. We want to multiply those data by 100, and we don't care about keeping the old data. So we are going to select as the destination the same as the data sets that are selected as the source. Source are the data that you want to change. Destination is where those data are going to be created, which in this case is the same as the source. And here you can put the formula that you want to use. So here in this case, we want to multiply all the y values of the dataset by 100. So we are going to write y equal y times 100. What this means is that Exenbrace is going to take all the y values of the datasets that you have selected, multiply them by 100, and use this value to update the y value. So if we do that, all the data have been multiplied by 100. So now they don't even appear on the plot because they have become too big. So if we do that, it means that we have now to change the axis again so that we can see the data. So the axis used to go between 0 and 0.4. So now it will go between 0 and 40. Okay, so we will need to adjust the axis again because now we have a 0.0 that we don't need. So we are going to first go back to general format, put a precision of 2 like this so that we have a percentage that goes between 0 and 40%. And we are going to change distribution by, we are going to add the information that it's in percentage. So we can do this like this. Okay, so now we have the distribution of students in percentage, which is easier to understand. It means that here for CE 105, for the black data, you have 20% of students that got a grade of 5. Okay, so the next thing we will want to do is now to add a guide, a line that is going to help us distinguishing the two datasets. If we just plot the data like this, it's not easy to distinguish the red ones from the black ones. So it's helpful to have a line that goes through the data to help showing the trend and distinguishing the two data sets from each other. So the first option is going to change the data again. So we can go back to the data menu and go to transformation. And the first option that we might want to use is to use an interpolation and spline. So the way the interpolation option works is that you select a given set of data, and you are going to interpolate the data to create a smooth function that goes through all the points that you have, but in a smoother way, just to have by just having a line that is directly joining the different data points. So the way it works is that, again, you need to select your source. So here we are going to start by the first set, the black set as 0, and you need to choose the destination. But this time we don't want the interpolation to replace the data themselves. We want to keep our existing data and just create a new smooth interpolation that goes through the data. So we are not going to select any destination. It means that Grace will create a new data set that will correspond to this new function that will interpolate the black points. So then you can select the method of interpolation, so linear, cubic, or Archimedes spline. So we are going to start with linear, although it's not very useful. And then you need to select between which x value do you want to interpolate the function. So here we are going to interpolate our data between 0 and 10. And here you need to select how many points do you want to interpolate the data in between the data. How many points do you want the new smooth function to be consisting of? So you need to choose something that is high enough so that your function looks smooth. So we are just going to choose 1000 in this case. So if we do this, you have again a very angular function that goes through the points. So this is not surprising because here we used the linear method to interpolate the data. So this is not exactly what we want, because this is exactly the same as having a straight line that goes in between the data points. So you know that when we have done that, XNGrace has created now a new set of data that is called G0S2, which is a new data sets that we can treat as a distinct data sets from all the other one that we can transform in a different ways. So now we are going to change the method from linear to cubic, for example, but this time we don't want to create a new data set. We just want to use the one that has been created, so that this linear interpolation is replaced by the cubic interpolation. So we can apply again. This time we have something smoother that looks much better. Okay, that very smoothly interpolate all the data points. So this looks good in this case. We can try the Archimedes spline, which also looks good, but maybe cubic looks better in this case. So in this case, the data are very symmetric and everything like this. So we a simple interpolation looks very good. But if the data were not as good, if there was a little bit of uncertainty on the data, the interpolation would not look so good. So to illustrate this, what we are going to do is to slightly change those data. So what we can do is, for example, double click on the data, select the set that we want to change. So for example, we want to change here the set as 0. And the way to change a set of existing data is to double click on those data, or to just do a right click on it and to select edit in a spreadsheet. So then here you have a spreadsheet just like Excel that contains the data. So for example, here what we are going to do is to change the data for the X7, and instead of having 12, we can try to put 13, or let's put even 14, okay, and we can choose the 8 instead of 6. We can put let's say 4, or let's put 4.5. Okay, so if we do this, now the data are not exactly where they should be, so you have a little bit of uncertainty in the data. So now if we go back to the interpolation, and if we try to interpolate those data, the result is going to be very different. So let's try to do this. This is what we get. So if we interpolate the data, the interpolation is always going to go through the data and just interpolate in between two data points. So sometimes this is what we want, but in this case, the interpolation doesn't look so good. It's because we know that there is some uncertainty into the data. What we would want is a smooth function that goes in between the data, that fits the data, not just an interpolation that makes those weird ripples here. So if you choose a different style like Akima, this is not gonna help. This looks better in this case, but it's not exactly what we want. What we want is, we see that the data looks like a Gaussian distribution. So what we want is to fit this data by a function for which we know already the analytical function, which is going to be, for example, a Gaussian distribution. So for this, we cannot use an interpolation. We will need to use a fitting. So we are going to delete this data sets that we just created, because we don't need this green data sets. So the way to delete a data set is, for example, you can right click on the data sets. You have different options like hide, show, bring to front, bring to back, etc. Duplicate. Here we are just going to kill those data, which means to delete those data. So we are going to stop the interpolation and use something else, which is in this case the nonlinear curve fitting. Okay, so this is what we want to use. So we are going to fit the data. Fitting the data means that you know what is the analytical function that you want to fit the data with. You just don't know what are the parameters, and you want X and Grace to find the optimal parameters that are going to fit your data in the best possible way. So this is a very common things to do. You can use it to either have some lines that will just be a good fit for your data, so that they can just be a guide for the eye and help distinguishing the different data sets from each other. Or sometimes you have a distribution of data. You want to, for example, model those data by a Gaussian distribution, and you want to use this to get some information about where is the maximum position of this data, what is the Fourier-Treffer maximum, etc. So here we are going to do this and fit those data by a Gaussian distribution. So again, you need to select the source of the data that you want to fit. So in this case, we want to start with S0. And here again, we are not going to choose any destination, because we want to create a new function that will be the fit of those data. That will be the Gaussian function that is identified by X and Grace as being the best Gaussian function that goes through those points. So here, then you need to select the formula that you want to use. So you need to write here the expression, the analytical expression of the formula that you want to use. So here we can select, for example, we can write any formula that we want, and we need to express what are the parameters that needs to be optimized by Grace for the fitting. So the first thing to do is to select how many parameters do you need. So for example, if you wanted to, let's assume you wanted to fit this function by a linear function, you would choose just 2 parameters. Those are the 2 parameters that you need for a linear function. The 2 parameters are A0 and A1. And then you can type the definition of this function. So for example, here it would be A0 plus A1 times X for a linear function. Okay, so if you try to do this, for example, XM Grace is going to try to fit what is the best linear function that fits your data. So here, obviously, a linear function is not going to work so well. So the fit is very poor. Sometimes it helps to press apply several times to see if the fit parameter can be further improved. But in this case, clearly a linear function is not going to work. Okay, so let's, for the sake of it, we can try a second order function. So by adding a new parameter a2, and say that we will add in the function a parameter a2 times x to the power 2. So in this case, XMGrace will try to interpolate or to fit this function by a second order polynomial. So note that when we do this, what XMGrace is doing is to create a new dataset that is S2, which again is the dataset that contains the fitted function, which is different from the data themselves. So let's try to this second order polynomial. So here it's much better. A second order polynomial is a much better representation of the data, but still it's not what we want. It's not perfect. The data looks much more like a Gaussian distribution. So here we have some information here in this space, which is the Grace console. We have some information about the fitting, about the R-square coefficient, the chi-square, as well as the fitting parameters. So those are all useful information to determine the quality of the fit. So here we want to fit the data by a Gaussian distribution. So we need to change the formula and select the expression of a Gaussian distribution. So we are going to put a pre-exponential factor, then times an exponential. So we're going to put the formula of a Gaussian distribution. So it depends on x minus a parameter a1 that is going to be the average position of the Gaussian distribution. This is to the square. This is divided by 2 times the sigma, so the standard deviation of the Gaussian, which is a new parameter a2 to the square. Okay, so here we have the expression for the Gaussian distribution. So when you are fitting the data with a function like this, which is slightly more complex than just a linear function, it's good to help XMGrace by providing some initial guesses for the value of A0, A1, and A2. So here we can try to help XMGrace a little bit by saying that we expect that A0 is going to be around 20, we expect that A1 is going to be around 5, and we expect that A2 is going to be somewhere probably around 2 in this case. Okay, so then we are going to apply to have the fitting going on. We can apply several times, and you see that the parameters are slightly changing as XMGrace is trying to further optimize those parameters. And here it's not changing anymore. It means that it has converged. Okay, so here we have a very good Gaussian distribution that very nicely fit the data. Okay, and this is much better. This is a smoother function that doesn't try to go through all the points necessarily, but just find the best overall fit for all the data. And we find that indeed the maximum of the Gaussian is around 20, the average position of the Gaussian is around 5, and the standard deviation of the Gaussian is around 2, which is what we expected. So here the fitted function still looks very pointy, so we have to change this by going into the advanced menu. Here what we are going to do is to have a smoother function. For this we need to change the load option. So here for now, the load option is just fitted value. What does it mean is that XMGrace is going to create a new set, and if you are fitting 11 data to begin with, which is what we have here, we have 11 black square, it's going to create a fit with only 11 data points for the same x. So this is going to look very pointy. So instead of this, we want to choose the option function. And here we have to select where do you want the option, the function to start and end. So here we will say it should start at 0, end at 10, and you have to select again, just like in the interpolation, how many points do you want the function to be made of. So we are going to choose, for example, 1000 to have something much smoother. So if we do that, we have now a much smoother Gaussian distribution that fits our data point. Okay, so we don't want this to remain in green, so we are going to double click on it to change its style and choose, for example, to put it in black and to increase the width to have something like this, okay, which is much more visible. This is much better than having the data points only, because it shows better the trend, and it shows that if we have a model, for example, if we expect those data to follow a Gaussian distribution, it means that our model is indeed a good representation of the data. So we are going to do the same now for the second set of data. For the red data S1, we need to remove the destination so that a new data set is going to be created and not to overlap with the previous one that we just created. And we are going to do exactly the same, fit those data by a Gaussian distribution. So we can just do it like this. You see that the first one that XMGrace is creating when you just click apply is not so good because it has not been fully optimized yet. So you need to apply one more time until you see a convergence of the parameters. So here it looks like it has converged. So this function looks good. So again, we are going to double click on it, put it in red so that it mimics with the symbol color that we have, and increase its width to be 1.5 so that it becomes more visible if you are going to present those data at a conference on a video projector, for example. Okay, so now the data look very good. The plot looks very good. You have a nice fit that clearly show the trend of those two data sets. So the last thing that sometimes we might want to add is to add some text inside the plot. So this is not always useful, but sometimes it helps to highlight a specific thing. So for example, if you want to do that, you can go into the window menu and select drawing object. And here you have different options of different things that you can add manually to the plot, like some text, some lines, some boxes, some circles, etc. So here, for example, we will just want to add a text to highlight where is the maximum of the black distribution, for example. So we will want to add a text. So we will want to select the option text. Then you need to click on the plot where you want this text to occur. Okay, so we are going to say, for example, something stupid like maximum. We can change different options like the color, like we are going to, for example, to put it this time in Helvetica oblique like this. You can change here its position, its size, etc. Okay, so this looks good like this. And then we are going to we want to put an arrow to indicate where the maximum is. So we are going, for example, to create a line. And here you need to select a line and select where the line is starting by clicking and where the line will be ending, like something like this. Okay, so this looks good, but we want to add an arrow and maybe make this line thicker. So we can go to the edit object and double click on this line to increase its width and add an arrow at the end and make the arrow a little bit bigger like this. Okay, so this creates a bigger arrow. Maybe we can increase the width of the arrow like this to make it more visible. Okay, so this looks good. So again, this is not always needed, but sometimes it helps to add this kind of elements on the plot itself. Now, the last thing that we want to do is sometimes you need to have special characters in the text that you are adding, or in the text that you have in your access. So let's review those things that you might sometimes have to do. So for example, let's look at the axis for the y-axis. So here we have student grades. Let's assume that we want to say that the student grade is named GS, like this, like grade for the students. And if we want S to be a subscript, so G subscript S. So the way to do subscript in XMGrace is to use the command /s. Every /s means that everything that follows is going to be a subscript like this. Okay, so we are going to use this here to say we just want to put S as a subscript. And if you want to continue writing some text after that, it's just going to be a subscript. So if you want to go back to end the subscript mode, what you need to do is /n, capital N, to go back to normal mode. And this ends the subscript mode. If you want to do a superscript, you can do the same thing and add this time /S. And here, everything that follows is going to be a superscript like this. Again, if you want to create a superscript, for example, like this, like for example, we can add the superscript AVG, like it's the average grade per student or something like this, and then go back to normal mode so that whatever you continue to write goes back to normal mode with no superscript or no subscript. Okay, the last thing that you need to do sometimes is to add some special Greek characters, which is very common types of character that we need to add. So for this, for example, if you want, let's remove this thing. If you want to say that the grade has a symbol gamma or any other types of Greek symbols, to enter Greek symbol, you need to use the command /x, and then everything that is following is going to be a Greek symbol. So if you want to come back to regular mode, here you cannot use /n for some reason. You will need to use the command /f like this. Okay, so if you use this command /f and then the parenthesis, this in effect means that you go back to the default font that you were using, so that you stop the Greek mode and you can come back to regular letters. Okay, so this is not so easy to understand why XMGrace is working like this in this case, so you just need to remember it. Another symbol that is very common is to use the angstrom symbol. So for this, you need to enter the special character mode, which is by /c. And the code for angstrom is capital E. So in that case, it would look like this and create an angstrom symbol. If you want to continue writing some text after this, everything is going to be a special character as well. So you would need to exit the special character mode by a /C, and then you can go back to write some default text. Okay, so those are not easy features of XMGrace, but you just need to remember those basic things about how to do a superscript, how to do a subscript, how to do a special character, etc. And then you don't need to remember this all the time. Okay, so the next thing that you need to remember, and which is a very big drawback of XMGrace, is that there is no undo button in XMGrace. What does it mean? It means if you do something wrong, if you delete a data, there is no way to just say, oh, let me undo this last action that I did. Which means that first you need to be very careful when you are using XMGrace to avoid doing stupid things that will make you start from scratch. Or what you can do is to save your XMGrace plot as often as possible, so that if something goes wrong, you can just go back to the previous file that you saved. So the way to save an XMGrace project is just to go to File, Save. Here you have the directory where you are working in. You see the different file that you have, and you can here select the name of the plots that you want to use. And typically for XMGrace project, the extension should be AGR, okay, which is the typical extension for XMGrace project. Okay, and when you do that, it will just save this plot, which means that in the future you can reopen this plot and continue working on it. Or you can reopen this plot and remove the data and put some new data, and it will keep the style of the plot. So that's gonna make it easier to avoid having to make a square plot with the ticks pointing out, etc. all the time again. So you don't have to. You can create some templates like this and having to just add the new data. So this is the AGR file. So it's the XMGrace file. This is the file that you always need to save because it's the file that you can reopen in the future in XMGrace to continue working with the data, add some new fits, etc. But this is not the plot itself. What we want also is to create to export the picture of the plot that then can be used to be copy-pasted in presentation or in a manuscript for papers, etc. So for this, what you will need to do is to export this plot into a picture. So the way it works is, again, to go to File and to export this file into a picture, you actually need to print this picture. So for this, you need to go to the print menu, and here you have different options, but here we don't want to print it on a printer, we want to print it to a file. Okay, so this, if we do this, this is going to create a PostScript file, a .ps file, which is a vectorial format, which is typically what we want for publication. So here, this is what we are going to do. We are going to apply and accept. And the next thing that you need to do after you have set up the print is to select print. And at this point, the file will be created. So you will have a new .ps file, a new PostScript file that will contain the figure itself. Okay, so now we have done everything that we need. We have properly saved the XMGrace file. We have exported the picture. Okay, so now we can close XMGrace for now and check that indeed a file plot.ps has been created. So if we open this this file, it will look like this. So we have the plot that has been created. Okay, the only problem with this typically is that it creates a lot of white space around the plot itself. So you could overcome this by changing the dimension of your plot when you print it in XMGrace. But a very simple way that I would recommend is to print using XMGrace your plot in a PS PostScript file and then to convert it into EPS. So how do you do that? You can use the command PS to EPS to convert a PS into an EPS file. You can use the option -r equal plus to avoid any rotation of the plot. So you just need to remember this, and here you just need to put the name of the plot that you want to convert. So you want to convert plot EPS into an EPS file, encapsulated PostScript. And when you do this, it will create now a new EPS file, and the interest of doing that is that it has removed all the empty space around the plot, which is exactly what we wanted, to avoid having any white empty space around the plot. And now you can use this EPS file to put this into a presentation or a Word document to have your plot being part of a paper or of a presentation. Okay, so this is all that we need to know for XMGrace. So there are a lot of other options that you can use in XMGrace, but that you can start to explore yourself. But those are the basic things that you need to know. So thank you for listening, and see you soon for another presentation video.